Good afternoon, students. So, in the last classroom discussion, we had the discussion on how the instructions will be executed. That is the instruction execution cycle. So, which will have two important steps. One is instruction fetch, and another one is instruction execution. So during this instruction execution cycle, we are making use of two important processor registers. One is the program counter and another one is the instruction register. So please try to understand how that instruction will be executed. Now today we are going to discuss another important thing which are called it as what we are calling it as this is the branching instructions we are trying to discuss. So now I would like to share my screen. So branching and generating of the memory addresses. So that is the today's topic for discussion. So the learning objectives of today's session is that it will develop the students' knowledge on understanding of the how the branching operation will be implemented when we are executing a program, branching instruction, and how the memory addresses are generated when we are making use of this branching instruction. Now coming to this earlier program, so what we are discussed in the previous class is that just if you want to add two numbers and store in the third number, so just we have written the instruction like this: C is added with the contents of A and contents of B. So this is in order to accomplish this particular task, we have written four important instructions. We have written that using load and store instructions. So if I want to add n number of integer values, how do we do that? So in order to add two integer values only, we have written four instructions pertaining to load and store instructions. So if I want to add n integer values, how we can do that? So for example, consider this scenario, how we can implement the addition of n numbers, n integer values. So first what we are writing here is that we are loading num1 into register R2. So load num1 value into R2 and load num2 value into R3. Then you add this R2 and R3 value and store that result again into R2. Okay, so what I am doing here is that so I am performing this operation. So R2 is loaded with the number 1 and R3 is loaded with number 2, and I am adding R2 and R3 and again I am storing into R2. So that means previous value of R2 will be replaced with the new summation value. Fine. So like this here again this num3 is loaded into R3, num3 is loaded into R3, and now R3 is added to R2 and R2 is stored in the register. So now again I am executing add R2 comma R2 comma R3. So that means again I am executing this instruction. So like this here, if we want to add n number of numbers, so now the n number of numbers will be available in the memory words like this here. Num1 is stored here, num2 is stored in this memory address, and so on. Num n will be stored in this memory address, like this, for example. So we are loading each operand value num1, num2, num3, and so on num n. So and we are adding that to the registers, and by making use of this add instruction, we are adding that. So this way, you have to write the sequence of load and add instructions. We have to write to perform the addition of this n number of integer values. So like this, num n has to be loaded into R3 and then add R2 comma R2 comma R3. Okay, so this load and store, load and add, this load and add instructions, these so sets of instructions has to be repetitively done n number of times because you want to add n number of values. Fine. And then finally, after adding all n number of values here, now the sum we are storing whatever we are available in the R2 final sum. So we are loading into sum variable, and the sum is available in the memory word here at this point. So now the sum will be loaded with the final result. This is the final summation will be available here in this particular memory word. So this means here, if we have n number of words, if we want to add n number of integers, so this load and add instructions, these two sets of instructions has to be repeated n number of times here we have to write. So assume that how much complex it is to do this particular operations. Okay, so this is what we are calling it as the straight line execution. So we have to write load and add. For example, if I want to add 5 integers, so you have to load this load and add instructions 5 times we have to write. So the addresses of the memory locations containing these n numbers are symbolically given as n1, n2 and so on nn. And we have to write separate load and add instructions are to be written so that we are storing the final summation into R2. So after all the numbers have been added, the result will be placed in the memory location pointed or named with sum. This is where we are storing the final result. So this is what the sequence or straight line method of execution to solve this particular problem for adding of n numbers. So if n is equal to 3 means you have to write load and add 3 times you have to write here. Please try to understand. So if n value is making use of different, for example, here in the previous scenario here, if you see that, so if we want to add 10 numbers, we have to write load and add instructions pairs 10 times we have to write here. So how complex it is if the n value is increasing here. So the alternative way for this is that because load and add instructions are, these two instructions are repetitively executed n number of times. So that is the reason the alternative for straight line execution of the program is that which we are calling it as a branching instruction. So here we are using a branching instruction, and how this branching instruction can be used for making use of a repetition through a loop which we are calling it as. So now the same program here, previous program which is used for adding of n integers. So the same program we are implementing by making use of a branching instruction. So in this particular scenario, please try to understand that in the same way, how many numbers you want to add, that n value we are storing in this memory word as small n. And the n1, num1, num2 and so on, num they are stored in the memory words like this. These are the memory locations where this operands num1, num2 and num are stored, and then the sum is the memory word where the result will be stored here. Now how we are doing here is that first how many numbers you want to add which is available in the n memory word, first we are loading that n value into the register R2. Fine. So this is the first instruction, we are loading the number of values n value into this R2. Suppose if n value is 5 means that you have to add 5 integers. Now R2 is loaded with the 5 value. Now clear R3. Now R3 is initially 0. Clear R3 means now it will clear whatever the contents, previous contents in the R3, that will be cleared and it is initialized with 0. Now here what we are writing here is that we are writing the code here. So in this what we are doing here is that we are writing the code or the instructions we are writing. So what the instructions we are writing here is that we have to determine the address of the next number and load that next number into R5 and add it to R3. Okay, so where that next number will be there, that next number what we want to add, that we have to load, okay, into the R5. So load next number, that is the number 1, number 2 and so on like that. We have to load every time, we have to load this R5 with the next number what we have to add to this register R3. So that means first in the first pass or first iteration, so num1 value is loaded. First iteration num1 value, that is the num1 value is loaded into R5. Now after loading that num1 value, we have to add that R5 value to R3. So what means, what it the instruction we will write here. So now R3 is added with R3 plus contents of R5. R5 register contents. R3 register contents we will add and we will store again in R3 register. Okay, so that means the num1 will be added to R3. Previously R3 is 0. Now R5 is loaded with num1. So num1 plus 0, which is again the value R3 stored is num1. Okay, then we are subtracting the R2 value. So what is that R2? R2 is having 5. So you want to add 5 numbers. Okay, 5 numbers you want to add that. So now after adding one number to this R3, so now what we are doing here is that R2 value is decremented by 1. So how we are doing that? By calling the subtract operation. Subtract R2 comma R2 comma hash 1. So this we will discuss that. Hash 1 is nothing but we are just this instruction is equivalent to R2 is equal to R2 minus 1. Okay, we are subtracting the value 1 from this R2 register and again the result will be stored in R2. Then R2 now becomes 4. So now after that what we are doing here is that this is very important instruction which we are calling it as a branching instruction. So branch if contents of R2 is greater than 0. So if the contents of R2 is what? 4. 4 is greater than 0. So you have to branch to a memory location pointed by this memory word loop. So that means now the control will jump to this memory word pointed with this loop. So now what it does again, it will repeat that next, it will load the next number into this R5. That is number 2 will be loaded into R5. In the second pass, number 2 will be loaded into R5. Now it will be added to R3. So now R3 is nothing but previous value is what? R3 is containing the previous value num1 value. Now num1 plus num2 will be added and the result will be stored in R3. Then now R2 is subtracted. Now R3 becomes 3. So again condition will be checked here. If branch R2 is greater than 0, the contents of R2. So when we are enclosing in square braces, the process register is enclosed in square braces means the contents of R3 has to be compared here. If 3 is greater than 0, as condition is true, we have to jump to the loop. So now here we will jump to that. Next, it will load the next operand value into R5. That is R3 will be loaded, num3 will be loaded into R5. So like this will be starting the next iteration, next pass, third pass will be started. Now the third num3 will be added to here, R3, and then R2 value is decremented. So R2 value becomes 2, and again contents of R2 will be checked. Is it 2 is greater than 0? Yes. Again the repetition, next pass will be repeated. So like this, what happens here is that when we have added all the 5 values num1, num2, num3 and num4, num5, so now R2 value becomes 0. Okay, because R2 value is decremented every time. So when if R2 value becomes 0, now it will not jump to this loop. Okay, it will not jump to this loop uh, memory word pointed by this loop. Okay, so it will come to the next statement immediately. So what it does now, it will store the result which is available in the R3 into the memory word sum. So here the final result will be stored. Okay, final summation value is stored in this memory word sum. So this type of program coding is called it as a branching we are using here. So this is what we are calling it as branch if we are checking the contents of R2, and this is how we are generating the looping or iteration we are generating in this particular processor instruction execution. So this is what we are calling it as a branching. So this is what the program instructions by using a loop here. Okay, so this is what we are calling it as. So to implement a program loop in which the instructions read the next number in the list and add it to the current sum. So to add all the numbers, the loop has to be executed as many times as there are numbers in the list. So it starts at the location loop and ends at the instruction branch if R2 greater than 0. So during each pass through this loop, the address of the next list entry is determined and that entry is loaded into R5 register and added to the R3 register. Okay. So assuming that the number of entries in the list is n and it is stored in the memory locations as shown in the diagram. So now the register R2 is used as a counter to determine the number of times the loop is repeated. So every time R2 initially R2 is loaded with the n value and R2 is decremented by 1 every iteration. So when R3 becomes 0, now we are stopping that all the n number of integers has read and they are added to that particular sum. So and finally the result which is available in that R2 will be loaded at the sum memory location. So this type of instruction loads a new address into the memory program counter every time. So as a result, the processor is going to fetch and execute the instructions at these new addresses and which we are calling it as a branch target. So instead of the instructions at the locations that follow the branch instruction in sequential order of execution. So this is what we are calling it as a conditional branch instruction. So which causes the branching only if the specified condition is satisfied. So if the condition is not satisfied, now the program counter is incremented in the normal way and the next instruction in the sequential address order is fetched and executed. Fine. So this is what we are calling it as a branching execution. Now at this point of time, now one question for you, that is a reflection point one. So what is an alternative way for straight line execution? Anyone? So what is an alternative way for straight line execution? So that is what we have seen with an example of adding of n integers. So instead of an alternative straight line way of executing, so we can make use of a branching execution or looping execution, we can use that. Now, how do we generate these memory addresses when we are making use of this looping execution basically? So the memory addresses can be generated so that we can make use of some register Ri so that it is used to hold the address of the first operand we are storing into this Ri register. That is the first operand here is nothing but num1. So first initially Ri register is stored with num1 and in every iteration now this Ri register is incremented with the 4 because word length is 4 bytes so that it will get the address of the next operand n2 num2 value. So that is how we can generate the memory addresses of the operands in such a way that we are executing or we are updating this Ri register Ri by incrementing that contents by 4 on every iteration of the loop or on every pass of the loop we can increment that Ri value by 4. Fine. So this is what how we can generate the memory addresses. Now coming to this today's lecture level problem is that so you have to solve this problem and write the branching instructions to find the factorial of a given number. So generally you will, how do we find this factorial of a given number? Suppose if you are given n is equal to 5. So how do we find that? So you will multiply 5, 4, 3, 2 and 1. So this result you have to display as a 5 factorial. That means you are starting from the given n value and you are every iteration in every iteration n value is decremented by 1 until when n becomes 1 you have to stop this repetition of this multiplication operation. Okay, so please try to write that instructions for performing this particular problem. Fine. So thank you for patient listening for this and the today's lecture outcome is that you must be able to develop the code for a given problem using the branching instructions. Okay, so thank you one and all.